Hi, Professor. My team will be presenting our project implementation of Ludo game, and the team members are Priyanka and Devi Ratnasuri. So, moving to our first portion, which is introduction. So, within a Ludo game, it's basically a board game consisting of 2 to 4 players, and each player is assigned a specific colors, and it's provided with 4 tokens. In this board game, 2 to 4 players are required to play their tokens from start to finish according to the roll of a dice. And our Ludo game is at the same shape of a cross, where each arm is being divided into 3 adjacent columns of 6 squares. Middle squares from each player goes to the home column of each color, and it cannot be landed upon by other colors. It leads to the home area divided into 4 home triangles, one for each color. At each corner are colored areas where tokens are placed to begin with. Typical colors are seen in Ludo games are yellow, green, red, and blue. And each player are assigned with, as I mentioned before, a single color and 4 tokens matching that color. So as the game starts, all the tokens are at the starting circles, and movement of the tokens is decided by the roll of a dice. If a player gets a 6 on a roll of a dice, he can make the move. And there are several strategies which needs to be maintained, which we'll be talking about later on. So basically, the motivation of this project came from a point where, this is like a game where we need to strategize the rule system. So modeling the rules of the game is easily and understandable, allowing the specification of different player strategy, stimulating, storing, and flexibly replaying different games, visualizing the game and allowing user interactions, and offering high performance in simulating games. Moving to the next portion of this is what are the tasks and purpose of this particular expert system. So basically within this game there are 52 field rings in the form of a cross. So we'll be showing you our board where you can see the 52 fields. And there are 4 players, red, green, blue, yellow, and they have their 4 tokens and at the home location. Every 13th field will be serve as an entry field for a player to the home location, and the turn comes in a cyclic way. So at every point in time, it's always a one-player turn, and the next one comes to the next player's turn. So let's say if a player, it's one player turn and he gets 6-sided dice moves. So basically he can do an entry. So for example, if a die shows 6, the player can still take out the tokens at the home location and then start occupying the tokens of his own in the field. And second is a forward, which is if no entry move is possible, the player must select one of his token on the board and move it forward by the exact number of eyes on the dice. The last point is if a dice roll was 6, the same player takes another turn. Otherwise, the next player gets the next turn. And finally, the game ends when one of the player has occupied all his goal fields, and that player wins the game. Now, basically, this game works on a strategy, 4 basic strategies like aggressive, defensive, move first, and move last. Aggressive is like give preference to move that kicks the tokens. So, for example, if a player is playing and there is another player's token at a particular position, that strategy is given a preference where we can the player can kick off another player's token. Defensive is giving preference to move the target field when the token cannot be kicked. Move first is give preference to moving the foremost token, and move last is give preference to moving the hindmost token. So um, And more specific strategies, sophisticated strategies can be defined by taking the moves of other players. So basic elements of our models are board GUI, graphical user interface, images which have used to represent dice and board, then token movement logic, and the console. So basically console, as we make a move, the console will display the predicted value of dice and the position of a token on the board. So when we do a demo, you'll be able to see that in detail. Now I'll hand it over to Devi to present next items.
Yeah, so I will presenting the next one. It's about the knowledge source and knowledge acquisition. So for our projects, we find some more sources from research papers and also some from the books as well. So in the current day, it's common for people in all age group to engage in playing games. So and also it's one of the subjects from the like for people to get some entertainment, especially when the artificial intelligence is involved. The game usually is like more interesting compared to the normal a game. So it's like more, yeah, interesting to the user. So so the AI itself, it requires knowledge to investigate the mechanism by learning from the knowledge through experience. So the knowledge is some result from someone when they understand the information and it has proceed. It is a process that often has been used when information is needed to be used for critical decision making. Obtaining knowledge from various sources, such as human experts, books, videos, database, and encoded into knowledge base could help the computer answer question posed by the user, as well as show conclusion constructed on the knowledge base. So for our cases, because of its in the Ludo games, they have their own instruction and the rules what they have to follow, and it will like adjust as well by how the player gets some steps and the action. So for the Ludo game, we are implementing key learning to make the game more interactive. So the key learning is a reinforcement learning method that investigates how to behave in an unknown environment to find the optimal action selection policy using a key function. So if it evaluates the next steps that AI has to run subjected to a action value function that control that value on a certain state, as well as taking specific action on that state. So the purpose of this is to find the best action for each state and maximize the expected reward by selecting the best possible action. For the next one, it's the knowledge design and engineering. So for this design, we are reference to one of the papers. So this is the explanatory type graph for the Ludo case. So it's shown in the figure number 1. So in here, so the player is represented by a nodes that enable the player to have an identifier or the color to distinguish one to another, and usually is modeled distinctly through edges. And a token is the thing that belong to the player, and it's also represented by nodes, which is usually modeled by an edge or by an attribute. And fields is represented by nodes, which is an entry, and the goals are a special type of fields. So each player, they have their own fields as well. And for the board, it contains all the fields as well as the interconnection, which could be turned into nodes and commonly modeled by edges. And it, however, it does not necessarily need a special node because it indirectly belongs to it. So for the dice is represented by a node, sometimes integrated with some existing node, somehow could be a special kind. So the result from the dice roll is typically element of the dice node. So for the strategy, sorry, for the strategy is represented by a node or an attribute which allow the player to assign strategy by adding an edge or attribute. So the GAN rule sets some limitation in choosing which token has to move, as well as performing to move. So in here we are implementing priority enforcements. So for example, it's like only move that according to the enable rule. So generally is required the move that is modeled by a single rule, which is move the token immediately to gold field. In addition, we also apply posteriori enforcement. So, for example, a move is tried out and rejected if it's lead to an illegal state by marking the token as immovable. So, since the result from roll dice must be random, a function is called to generate the randomness. So, the key learning from the a real player objective is applied to the agent to select the best applicable activity for a given state. So the agent will learn like from the behavior from the other player as well, like what the next steps that they have to get. So basically there's like a four different move. Sorry, it's like five different strategy like defensive, aggressive, fast, random, and prefer release. So the reward are provided immediately after the selecting to move. It designed to encourage the agent to pick moves that achieve a combination of winning the game, release a token, defend a vulnerable token, knock an opponent token, move tokens closest to home, and form a blockade. So the reward are accumulated in order to encourage the agent for the maximal achievement. So this is the user interface of the Ludo game. So this is when we open the when we run the file. So this is will be the first interface. So the user they have to enter that how many players that they will play this game. So they can choose either playing with the computer or playing with friends. So if the user select play with computer, the game will start within 10 seconds automatically, and then the user will get the color is the blue one, and then the computer will be the red one. And also if the user choose the player play with friends, the user have to enter the number of the players that will play the game between 2 and 4, because it's like they need one more person to play, and or four people is maximum, but cannot more than that. So this is the example. If we select the number of players more than 6 and more than 4, it will show like please input number of player between 2 and 4. And when the selecting number of players succeed, this is the board that will show. So the predict button color is become highlight green. So that means it's your turn that you have to select the predict button to roll the dice. So for this is the example when we roll the dice and we got a 6 die, and then we can choose either the token number 1, 2, 3, or 4 to get out from the board field. And then after that, yeah, we can just if we got roll number 6, we have a chance to roll one more time, and then we keep taking turn between the computer and us. So if the one of our token reaching the goal field, it will show the notification like congrats, you now at the destination. So if the computer or like our opponent reaching the destination, we also will get the notification like, hey, I am at the destination. So if like what we mentioned before, if illegal states, they will show like a no path is available, and then it won't let the token to move. And then if there is a winner with the 4 token reaching the goal, it will show like hurrah, hooray, I am the winner. So in this case, the computer winning the game because there's like 4 tokens in the goal field. And then yeah, this is the end of the UI, and I will pass it on to the Priyanka again.
Thank you, Devi. Now I'll talk about game implementation. So our game will be opened by executing main.py script, and the user will be asked to enter the number of players as well as input of the playing with the computer or playing with the friends. And then the game interface will be shown. So for the implementation part, we'll be giving the demo. For the requirement, we are using Python 3 or higher is required for implementation of this project. Then pip package installer is needed to install